This is the third video for the topic chapter motion. We saw speed in the last video. Here we will be discussing velocity. Before coming to velocity, we know this is a speedometer. In the speedometer there is one more reading, one more meter, which shows the distance travelled. This meter which shows the distance travelled is called an odometer. So speedometer tells us the instantaneous speed. Odometer helps us to find the distance travelled. Now coming to the next topic, velocity. How did we define speed? We say speed is change in distance with respect to time, that is rate of change of distance. So in speed we measure the total distance travelled to total time taken. What is velocity? If speed is change in distance, velocity is change in displacement with respect to time. So we say that velocity is displacement by time taken. Both speed and velocity can have similar units. As we said, speed has the unit of meter per second, centimeter per second, kilometer per hour. Velocity can also have similar units. Now the SI unit of speed is meter per second. Similarly, SI unit of velocity is meter per second. The only difference in speed, it is change in distance with respect to time. Velocity is change in displacement with respect to time. Now because displacement is a vector quantity, it focuses on the direction. Velocity also focuses on direction as well as magnitude. Hence velocity is also a vector quantity. Now with an example, let's try to understand how the speed and velocity different. For a common man, speed and velocity mean the same. Let's take A is Surat and B is Mumbai. This route has a distance of 300 km and let's say this route has a distance of 350 km. Or rather, let's say 360 km, just to get an approximate exact value. Let's say we took 5 hours to travel from this route and we took 6 hours to travel this route. 6 hours. Let's say this is X's route and this is Y's route. Now, speed of X. What is speed? Speed is distance by time. What is the distance travelled by X? Because X followed this route, the distance travelled is 300 km. And what is the time taken? 5 hours. The speed of X is 60 km per hour. What is velocity of X? Now we know velocity is displacement by time. Because X has followed this straight path, for X distance and displacement both is 300 and the time taken is 5 hours. So velocity of X is also 60 km per hour. So for X both speed and velocity has the same value. So when will velocity be equal to speed? If the object is traveling in a specified straight direction. Now let's look the same for Y. For Y, the speed of Y would be, Y has travelled total distance 360 km in 6 hours. So the speed of Y is 60 km per hour. So Y has the same speed as X. What is the velocity of Y? Now Y followed a slightly convoluted route. So to reach from A to B, the total length of the path that Y took was 360 km. But what is the displacement? We know displacement is the shortest length between the initial and final point. So for Y, the displacement would be 300 km. But the time taken would be the same time, 6 hours. So the velocity of y is 60 km per hour. Yes. So that is how velocity differs from speed. Velocity takes displacement into consideration and speed takes distance into consideration. Again from this example we can understand that speed will always be equal to velocity or more than velocity. Why? Because in speed you are taking distance into consideration. Now distance will be always greater than or equal to displacement. Now if distance is equal to displacement, speed and velocity would have the same value. But if distance is greater than displacement, speed will be more than velocity. And distance is never less than velocity, hence speed will never be less than velocity. So that was velocity. Again, instantaneous velocity. Now what will be instantaneous velocity? Whenever you are calculating velocity for a very short interval of time, the change in displacement for a very short interval of time, that velocity would be instantaneous velocity. And average velocity? Average velocity would be total displacement by total time taken. Let's say a car is traveling at a speed of 40 km per hour. After 5 minutes, its speed becomes 60 km per hour. So this was the initial velocity and this is the final velocity. This will help you in numericals. The initial velocity is denoted by the alphabet u, small u. So you will say in your data part that initial velocity u is 40 km per hour. The final velocity v is 60 km per hour and time t was 5 minutes. So we denote initial velocity by u and final velocity by v. Now as we said, average velocity is total displacement by total time. Now let's say if this change in speed was gradual, that is when the speed of the car changed from 40 to 60 in 5 minutes. If the change was gradual, that is the change in speed was uniform, then we can also say, we mathematically represent that average velocity is initial velocity plus final velocity by 2. We can use this formula only when the change in velocity is gradual and not haphazard. What is u here? U is the initial velocity, v is the final velocity. So average velocity we write mathematically, it is u plus v by 2, initial velocity plus final velocity by 2. Now in the next topic we will look at few graphical representations. First graphical representation that we are going to look at, we will look at distance time graph. Distance time graphs for different motions. Now before starting distance time graph for different motion, I would like to take the topic of uniform motion and non-uniform motion. What is uniform motion? Whenever an object travels equal distance in equal interval of time, then such a motion is called uniform motion. Let's say at time 8 am, an object is at origin, that is, this is the distance, it is at 0 distance. Now after 1 minute, the object travels a distance of 10 meters. In next 1 minute, the object travels another 10 meter. In next 1 minute, the object travels another 10 meter. So we observe here that every 1 minute the object is traveling 10 meters. So we would say the motion of the object is uniform motion, because the object travels equal distances in equal interval of time. What is non-uniform motion? If an object does not travel equal distance in equal interval of time. Example of uniform motion, maybe we could say the hands of the clock. Hands of the clock travels equal distance in equal interval of time. So they are performing uniform motion. The motion of planets, they travel fixed intervals in fixed interval of time, hence their motion is uniform. Non-uniform motion, normally when we drive on the streets due to traffic, we cannot travel or we cannot drive at a constant speed. The speed increases, the speed decreases based on the traffic. So we are continuously changing the speed. Now because the speed changes, if the speed is more, we would travel more distance, and if the speed is less, we would be traveling less distance in the same interval of time. Now here the object is not traveling equal distance in equal interval of time, so its motion would be non-uniform. So that was uniform motion and non-uniform. Now let's look at distance time graph for different kind of motion. First, we take distance time graph for a body at rest. Let's say this is our coordinate axis. This is the origin. On y-axis we take distance. Let's say it can be in any unit. Let's say we are taking distance in meter unit. And on the x-axis we are taking time. Let's say it is in second unit. Let's say that at time 0 the object is at this point. Now the object is at rest. So after 5 seconds the object will lie still at the same position, because it is at rest, it is not moving. After 10 seconds it will be at the same position. At 15 seconds it would be at the same position. So if you keep on joining this line, you get a straight line which is parallel to the time axis. So we say distance time graph for an object at rest is a straight line parallel to the time axis. So you have to keep in mind, if they have given you a distance time graph and the graph, the curve, this is the line graph, and if they ask you to identify the motion, so when you notice that the distance time graph is a graph which is parallel to the time axis, when will be the graph parallel to time axis? When the body is at rest. So you will say that the motion of the body is, the object is at rest. Now let's look at distance time graph for a body performing uniform motion. Distance on the y-axis, time on the x-axis. Let's say this is time and this is distance. Let's say at time 0 the object is at rest at the origins. So this is where the object is. Now let's say after 5 seconds the object has travelled a distance of 10 meter. Suppose this is 5 seconds and this is where is 10 meter on the y-axis. So this is our coordinate. After 5 seconds it is at 10. Now because the motion is uniform, after another 5 seconds, that is after 10 seconds, it would travel another 10 meter. So the object would be at 20. So in the next 5 seconds, that is from 5 to 10, it travels another 10 meters, so now it is at 20. In the next 5 seconds, that is after 15 seconds, it travels another 10 meter, so it comes to 30. So this is 15, the object will come to 30. So now if you join these points, you get a straight line like this. So such a graph wherein for a distance time graph you have a straight line inclined to the time axis. Such graph indicates that the motion is a uniform motion. Yes, this is distance time graph or uniform motion. Now non-uniform motion. Distance time graph for a non-uniform motion. Distance time graph for a non-uniform motion is a curve like this. This is for non-uniform motion. So you should remember these are the three graphs for distance time graph. Distance time graph for body at rest was straight line parallel to the time axis. Distance time graph for uniform motion was straight line inclined to the time axis, and distance time graph for a non-uniform motion is a parabolic curve. Now let's look at velocity time graph. Velocity time graph. First, body at rest. On y-axis we have velocity, on the x-axis we have time. Now because the body is at rest, at time t0 the velocity will also be 0. After 1 second, the body is at rest, so the velocity is 0. 2 seconds, velocity will 0. So for a body at rest, the x-axis will be your graph. Hence, you will observe that for an object at rest, the velocity time graph is the straight line which is represented by the x-axis. Now let's look at a velocity time graph for a body performing uniform motion. Velocity time graph for uniform motion. We know for uniform motion the body will have a constant speed. Let's say this point is the speed of the object. Now at time t is equal to 0, this is the speed. Now if the body is performing uniform motion, the speed will neither decrease nor decrease. It will move at a constant speed. So let's say at time equals to 5 seconds, the speed is neither increasing nor decreasing. After 10 seconds, the speed remains the same. After 15 seconds, the speed remains the same. So if you join, you get a straight line parallel to the time axis. In distance time graph, a similar graph is for body at rest. For velocity time graph, if you have such a graph, you will infer that the body is performing uniform motion. Now let's say the speed increases with time. At time t is equal to 0, the velocity was 0. Let's say after 5 seconds, the speed is 5 meters per second. After 10 seconds, the speed becomes 10 meters per second. 15 seconds, the speed becomes... That is, as time increases, speed is also increasing. If speed increases with time, such a motion is called accelerated motion. We will be discussing it in the next video. So you get a straight line. Such a motion is called uniform acceleration. So this is velocity time graph for uniformly accelerated motion. Now if speed would have decreased, the opposite of acceleration is retardation. So for velocity time graph, where the speed is decreasing, you will have a line like this. Here the speed is increasing, so it is uniformly accelerated motion. Here speed is decreasing, it is a uniformly retarded motion. This is uniform acceleration, this is uniform retardation. Yes? So these are your velocity time graph and distance time graph. I'll end this video. Thank you.